Hi guys, hi gals. I'm Łukasz, and I hate Unicode in Python too. As I said previously, I work at Deployed. You know the drill. If you like doing stuff, you can apply to work with us. One thing. A quick, maybe not quiz. Let's say just think about this thing, this line of code. How many times do you think a string is encoded and decoded in total here? Think about it for a moment. If you think you know how many times, I almost guarantee you that you are wrong. So, one thing that we will get back to this, so don't worry. One thing that you have to first differentiate when you talk about Unicode in Python is whether you are talking about Python 2 or Python 3, because as you know, much has changed for the better in Python 3. Fortunately, and we will get to this. So first we will start talking about Python 2. So in Python 2, you have basically two types which denote strings. The one type is string, which is as well. Okay, we will get to this later, but well, it's how do you type it? You type just apostrophes or quotes, and you write your string, and this is a string. And also you have the other dreaded thing, which is called Unicode. And you have something that's, in theory, a byte string, but it's the same, the exact same thing as string in Python 2, of course. And there is one very important question that you should ask yourself when you are programming in Python and using Unicode, is what exactly is Unicode? Because a friend of mine, who may or may not be called Janusz, said that he always thought that UTF-8 was what we are talking about right now. That's the Unicode in Python, and unfortunately, this cannot be further from the truth, because this is the text in UTF-8 is a str. It's a string, and how you can how you should think about this. Strings in Python 2 are just binary data. They are literal. They simply are bytes. These are just, ones and zeros, whereas Unicode is this abstract thing, and I cannot stress this enough. Unicode is the abstract value that signifies something that we usually call a string, but it's not a string because Python 2. Underneath, it's stored as usually as 4 bytes, but you don't care about it. You should not care when you are writing things in Python in Unicode, because what you should remember is that Unicode is, you just use it. I know that it may sound complicated, stupid, but we'll get back to this later again. And how do you convert from Unicode to string and from string to Unicode? Well, you take the Unicode string and you encode it into, name clashes. You take the Unicode object and you encode it to a string. You take the abstraction and you convert it to something physical. I'm purposely repeating this because this is the thing that I would like you to remember from this talk. This is the thing that will, if you have troubles with Unicode, that will make you not make the mistakes that you're probably making if you're making any. And also, if you want to convert from a str to a Unicode object, you decode it, which means that you take the array of bytes, you provide the encoding, and this gives you a Unicode string that you can then work on. So again, the encode method gives you, as a result, gives you bytes. The decode method gives you the abstract value that is a common string. So when you write your programs, what you should strive for is first what you get from the outside. You get the array of bytes, be it from the network or from the file. This is the array of bytes that you're usually getting. This is the str. What you should strive for is to first decode as early as possible to get the Unicode object. Once you have the Unicode object, then you perform all the operations on it as long as you can, and then at the very end, when you want to either send the response through the network or write something down to a file, just then you encode it to the str and then you write it down. Doing so will ensure the least amount of bugs in your code. Also, there are two rules of the Unicode club. The first rule is you do not decode Unicode, and the second rule is you do not decode Unicode, because then, if you do that, really strange things happen and you really don't want to be there. I mean, you want your friends to fix that bug instead of you. The same thing is with encoding strings. You do not encode it because strings are a result of a Unicode object being encoded. If you want to encode a string, you will get errors. The problem with Python 2 is that you won't get those errors all the time, only if the string is not a pure ASCII string. If you have some Polish, German, Spanish letters in it, just then it will fail during the encode process. If you put some regular ASCII letters, everything will work fine, and you will think that, well, it just works, it passes all the tests, so it might be okay, which is not. The thing that you also have to keep in mind when working with Unicode is the automatic type conversion, meaning that if you write something to a file, for example, as I said previously, what you have in a file, you have a series of bytes, right? No one has any abstract thing inside a file because it's not possible. It's something on the disk, and on the disk you can just have bytes. So the write function, or rather method, what does it do in Python 2? Whatever you pass it, it converts this thing to a string, which means that, again, you will have some issues if you pass some Unicode objects as the argument, because, well, shit happens when you try to encode stuff sometimes. And also, you have to be wary of some libraries. When you are using a library that accepts a string or some Unicode, unfortunately, you have to read the documentation, or maybe sometimes take a look at the source code to realize what's going on, because otherwise you will have issues with using the method. The other thing with automatic type conversion, I mean, the places where I have found the biggest amount of bugs is the formatting functions. So if you take foo and format it with the bar variable, the bar variable will be automatically, implicitly converted to the type of foo. So if foo is a byte string, bar will be converted to the byte string while calling the format method. If foo is a Unicode, then bar will be converted to Unicode as well, producing errors in the process. The same thing is with the percent formatting and the template formatting. Out of curiosity, does anyone use template formatting here? That's what I thought. No one. Okay. So the other perplexing thing, and also that's the slide which explains what I wrote in my abstract for this talk. If you want to encode something, and this also explains why you shouldn't encode when you shouldn't encode strings. If you want to encode something, foo, which has had the encode method called on it, will first convert the foo object to Unicode, meaning that the encode method actually takes encoding, and it just does coding encode self UTF-8, for example. And the same thing goes for decoding, which means that if you pass, if you want to decode a Unicode object, you'll have a problem because the Unicode object will first be encoded to string in order to be able to be decoded to Unicode. So that's when you get the decode error when you're trying to encode, and you get the encode error when you're trying to decode. So having said that, it's quiz time. And just one word of caution, this is most of the presentation, so we won't go further if you don't give me answers. So now it's time to wake up. So let's say you have this file. This is an actual snippet of code that we had in our company that has been slightly modified. We will see all the possible modifications that we can have. You will see in 2.py, 3.py, etc. The question is, what will happen if I execute this code in Python 2? And for the record, we will do the same with Python 3 afterwards. So if you're not coding in Python 2, don't worry. Your time will come later. So now, what we have here first is coding UTF-8. This, if you don't know, this simply tells the interpreter that everything below is encoded with UTF-8. So right now, what we are trying to do is we are opening the export CSV file as a writable file, and we write tralala with ASD-EW. So now, what do you think will happen? So exception, nothing, meaning I understand that you mean that it's okay. So who thinks it's okay? Leave the...
No, but it will work.
Okay, who thinks it will throw an exception? Oh, come on, there are no 4 people in this room. These hands don't sum up. Okay, so actually it will be okay, sorry, but this is the first slide that I've started with. Why? Because the thing is, everything here is okay. We are trying to write to the file. We are trying to write. Let me this way. We're trying to write. Yes, but you won't see it if I use the laser. You're trying to write something to the disk, and what will happen is that write will expect a string. A Python string, which is here, so it's okay. And you are formatting a string here into this one, which may look wrong, but remember that we are using the encoding, that everything that's here is encoded using UTF-8, which means that what you will have here is a simple array of bytes, and the EU here will simply be encoded in UTF-8. So actually this is one of the few examples that don't cause any problems, any issues. Now, moving forward, what will happen this time? What we have changed is we have switched the byte strings to Unicode objects. So what will happen and why? What do you think? Yes, so?
Unicode doesn't have method format?
We are talking about Python 2. It will, I mean,
Encoded with the default encoding that you didn't pass to the open, but there is an implicit default one.
yes, and what is the default?
Maybe you give it, I don't know. In Python, maybe something else. Maybe
Okay.
there's like a sys default encoding.
Okay, what will happen is you'll get an exception, so yay, finally something. We'll get a Unicode encode error. The ASCII codec cannot encode the EU letter at position 12. Position 12 is, well, it's not here actually, it's this string. So what will happen first? We will go from the right to the left. We have the tralala string, the Unicode string here, that is formatted with a Unicode object. So it's okay. We have Unicode here, and so we get a 12-byte string, 12-byte Unicode object. I'm gonna make this error quite often today. We get this 12 bytes Unicode object that will have then to be passed to the write function. The write function or method expects a byte string, so it will try to convert this to a byte string using the default encoding, which is ASCII, and will fail in such a way. So if you see something like that and don't know why, then you have to think that, maybe write expected something else, so has made a conversion. The third thing, the third file, we have a Unicode object to the left and a byte string to the right. Maybe. Does anyone have any other? Yup. As you can see, you have UnicodeDecodeError, which means that the error happens while converting from this byte string to this Unicode object. As you can see easily, this is the third position. I mean the position 3, which means we are talking about this string, which has 4 bytes. As again, we wanted this. Oopsie. We wanted this to be a Unicode object, and so the default codec was used, which was ASCII. So this produces that error. Going forward, now we have a byte string here and a Unicode object here. What will happen? Exactly. It's the reverse situation that was here. So we have 2 different types, the byte string here and the Unicode object here. So we will have that implicit conversion from Unicode to byte string. And again, we are using ASCII, so there will be a problem. The next 4 files that we will be using is just to check what happens if because right now, as you can see, we were opening the file as text, and right now we will open them as binary data just to see what happens. So let's try to go a bit quicker. This time, what will happen here? Sorry? Yep, exactly. Just as with the first file, it will be fine. When we have two Unicode objects, what will happen? Are you sure? Are you sure that it will be fine? You'll get the encode error because, again, this conversion will be fine, but then we were writing to a binary file, so we just need to have a regular string, Python string. Again, two different types. We have a byte string to the right and a Unicode object to the left. You're good. Decode error, again, on the third position, which means the error was here. And here, those who said encode error were right because, well, you see, actually, in Python 2, the errors that we got were exactly the same, both using the binary file and the text file. In Python 3, this may or may not be the same. So now, with the encode and decode functions, if we have such a snippet of code, exception, okay, but what? Exception and why? Method not found? Maybe you're talking about the wrong Python. And no, this is again what I wrote in the abstract. You're trying to encode something. You're trying to encode a byte string. So what happens if you encode a byte string? The encode method requires you to provide it a Unicode object. So it will do anything it can to get a Unicode object. So to get the Unicode object, it will just decode this byte string. And it cannot do that because it's still using the default encoding. So this is again the cause of getting a decode error when you're trying to encode something. And the reverse situation, I think you mostly already guessed. Yep, exactly. This will give you the encode error. Yeah, so how to do this correctly if you want to write things to the file, to a file? There is one way. One way is, of course, to encode or decode manually. Or you can, instead of opening the file using open, you can import the codecs module. And using the codecs module, you can open a file and specify an encoding, which means that when you will try to write a Unicode object to it, the file will know how to convert it because you will have provided that Unicode UTF-8 encoding, meaning that the following code will work just fine. So this is maybe not a workaround, but it's one of the ways of coping with writing to Unicode objects to files. Now, let's go and switch Pythons to Python 3. And we'll see why Python, maybe, well, this was one of the reasons, but why Python 3 does not have Unicode and why it's so much better. I mean, what am I saying? Why in Python 3 Unicode is the default string and why it matters and why it's really so much better. So again, what we have here is we have bytes, and the bytes are declared by prepending the string with a b. Everything that's in quotes or in apostrophes is a regular string, and again, the u prefix is exactly the same as a regular string. Again, almost the same slide as previously. Bytes are, well, bytes on ones and zeros, and the string is that mythical abstract value that you don't really know what it is, you don't really care about it, what it is, you just use it because you know that it can store every letter in existence. So let's do it one more time. This time, this file may or may not produce an error. What do you think? Method not found, you're saying? No, zero division is also out of question.
I think it's
Okay. Some people think it's okay, some people think it's a decode error. It's a syntax error, which means that this code will not run at all. Because in Python 3, the byte string here, the bytes, cannot have anything else than ASCII literals, meaning, you know, values from 0 to 255. And this is good. This is good because you cannot even run this code. It will fail early, and you will see that something's wrong with your code, and you will fix it right away. So that's one of the reasons why I think that moving to Python 3, moving to Unicode as default thing in Python 3 was great. So now let's move to 2.py. We're opening the file, and we have a Unicode object to the left and a Unicode object to the right. What will happen? An overwhelming amount of people are saying that it's fine. And yes, it is fine. Why? Because this time, Python 3, when it has to write something to the disk, it uses the default encoding, which is not ASCII anymore. Now, 3.py, we have bytes to the right. We have a Unicode object to the left. What will happen?
It's going to be fine, but not the expected behavior.
Depends what you mean by expected behavior. Yeah, so exactly, this is the syntax error. So now you again, you know at the first second of running your program that something is wrong here. And now? Will it be okay? Method not found, someone says. It will be okay or it will not be okay, right? I agree with you, that's a good answer. So again, Python 3 protects us this time because it says that you cannot do a format on a byte string. So again, this is yet another whole class of errors that we are avoiding right now because the code will simply not run. I mean, it will never run, which is very important because all those files that we've run on my slides previously using Python 2 would run properly had they not have the ew letter inside. If you'd have in both strings, if you'd have only ASCII numbers, those would have worked because the implicit conversion would have converted from one object type to another without issue. So it's okay, it passes all the tests. Okay, let's put it on production. And then you have someone who's called Fürti, for example. His username is Fürti with an umlaut, and everything crashes, and you have to debug something in the middle of the night. So again, this time we go through the 4 files, but we are writing as binary. Quiz time. Everyone saying syntax error? Sorry? Yeah, no format. No, sorry. Okay. Not this time. Yeah, it's syntax error because for some reason it picked that other error first. So you cannot have the ew letter in a bytes object. This time, what we have is two Unicode objects. Someone says it's, some people say it's okay. Someone says encode error. Okay, let's see what happens. A bytes-like object is required, not string, because unfortunately this time, and this is the difference between Python 3 and Python 2, is that if we have opened the file as a binary file, we are expecting to get here a bytes object. So this will work, but then this string, this string this time I can say, will be converted to bytes. Well, would have been converted to bytes. But again, Python protects you because it doesn't try to implicitly convert the object to strings, but it simply says, does not compute. Computer says no. Syntax error? Yep, exactly. That's good. That means that you're not sleeping, that you're following the lecture, the slides. And 8.py. Attribute error. Bytes object has no attribute format. So now let's go back to the encode and decode things. Methods, I mean. The encode here, what will happen? Attribute error, syntax error. Yes, syntax error because well, you have the ew here, but let's say that there was no ew here. Still attribute error? You sure? Yes, attribute error because this time again, Python 3 protects us, does not let us call the encode method on a bytes object. And now what if we decode a Unicode object? Remember, do not do this at home, at work neither. The string object has no attribute decode. So as I said, the advantages of Python 3 is that it does not convert strings to bytes, bytes to strings. It does not contain dangerous methods, dangerous like, you know, something that's so that you cannot encode bytes. And it catches all the potential errors at parsing time or, yeah. Some miscellaneous. I think we're slowly running out of time, so I will not click all the links. One thing that you can do if you are, well, actually, let's open this thing. Screw time. One thing that, oh, it's quite small. One thing that you can do if you're working with Unicode is that if you do not know what strings you are going to have passed to your program, and you're using Python 2, for example, well, the exception that you will get will be very cryptic because it will just say, you know, decode error or encode error, and you don't really know what was there, what was the the problem. So what you can do is you can a good workaround for this is to have your own exception here that you will use in your custom decode function that will just catch the exception and print a wrapper, for example, of the string that you were trying to encode or decode, so that you would see what was passed by the user. Because I'm talking of some situations where you do not control where where you do not control what's being passed, so you cannot really check it in your logs. Those are just thoughts that I had while doing the presentation, is that when you try to write something to a file with Python in Python 3, the local get preferred encoding is called to figure out to which encoding it has, which encoding has to be used to encode or decode a file, file data, which was the UTF-8 in Python 3 by default. So that's why the writing to file using Unicode objects worked. And also, again, it's not much used in production code, but sometimes when you have print statements, you may also experience conversions. So yeah, the takeaway. So this is again the time to wake up, everyone. If there's one slide that I would like you to remember from this presentation, is this one. So there are a few things on this. One is that bytes are just bytes. Unicode or string in Python 3 is this abstract structure, this something, and you get from bytes to string using decode, from string to bytes using encode. You do not encode bytes, you do not decode strings, and what you do is from the outside world, you almost always get bytes. Sometimes the library that you're using will convert it for you, but this may or may not happen. Double check that all the time. So then you decode early. In your Python application, you deal only with Unicode data, unless, of course, you're dealing with bytes because you're making operations on bytes, but that's another story. And when you want to put the data to the outside world, you encode it, but as late as possible. So doing this will ensure that you will not have issues with Unicode, or will at least minimize them. So the guessing game again. How many times do you think? Again, this is Python 2, for the record, because in Python 3 this will just crash and burn. 3, 4, 5, 6, 7, 10, 20. 5 times? You're good. You're good because yeah, this is 5 times. Because first thing is that the encode method requires a string. So the UTF-8 Unicode object will be first converted to string. Then you will have the foo encode, which will first decode foo to a Unicode object and then encode it. Then this will be formatted here, which will convert the bytes object to a Unicode object, and then the write method will convert it back. Please do not write such code. If you want to take a photo, this is the moment. Those are good, some good articles about Unicode, about the problems that you may experience also. And other than that, thank you for listening. And do you have any questions? Yes. The question was, what's the magic I use when I touch my screen? Well, I'm using a touch screen. No, this is. I mean, you're asking about. Let me. The Google thing has just a marker thing here. So when I move my my mouse, it just does that. So since I'm using a touch screen, which is fine because if I use two fingers, it works like this. But wait for me to use 4 of them. Okay, so there was also a question at the end. Yeah, kind of. Okay, so the second question, because the answer will be shorter, is whether I'm sure that both syntax error and attributes error will be caught by Python 3. Maybe I have misspoken. I think that only syntax error, because attribute error would, I think should imply that the interpreter is actually running the code to see what's the object that we are trying to fetch the attribute for. So I must have misspoken. And the first question was, do I have any hints or tricks for people who are porting from Python 2 to Python 3? Well, it's hard. It's hard to, well, one thing is that maybe you should try to use the 6 module, which lets you write code that will work both on Python 2 and on Python 3. So this way you can gradually port module by module your code, and there is much, I mean, this will make it easier to port everything gradually. That's one thing. The other thing is use the from future import something like Unicode literals, something division integral division integer. Yeah, the print function. I'm not sure if it's integer division or division, and also Unicode literals. Basically, just write those at the top of your file. And the third thing, have tests, which will then easily catch those issues. And besides that, there isn't really a silver bullet for that. Just you have to do it. Yes?
So in every Python 3 snippet, there is UTF encoding, and the question is it still necessary to pair it with Unicode default?
Yes. The question was whether the coding UTF-8 at the start of each file is still mandatory. Still does change anything in Python 3. It's not mandatory. If you want to write code in UTF-8, this is a default in Python 3. So if you want to use another encoding, then you will use that. But yeah, this is not necessary. I just kept this just because I wanted the files to be the same, or as close as possible to each other between the Python 2 and Python 3 versions. Of course, I have switched where I had the Unicode, the U string in Python 2. I changed that to a regular string, and bytes the other way around. But other than that, I tried to make them as close as possible. Yes, next question.
Do you know that you have an error on all the slides with the Python 3 and writing to the file? Can you switch to one?
Do I know that I have an error in all my slides for Python 3? Maybe. No, I don't know. Yeah?
I can see that you are trying to use different code for Unicode, but in the web open you didn't...
You mean the highlighting?
Yes.
Okay, you caught me. I was lazy. I didn't want to change all the strings, but yeah. But other than that, the code works. I can execute all those files right now in my console, and you'll see that the result will be the same as in my slides. Okay. Yes.
Do you know anything about internal representation of the Unicode type in Python 1, like Python 3, and how much heavier it is than
How much? Sorry, how much?
how much heavier than
Heavier.
how much more memory hungry they are, and if that representation is Python implementation dependent.
Ooh, that's a tough question. The question was if I know how is the Python the Unicode implementation in Python done? If it's heavier than in Python 2, and what again? And is it implementation dependent? From what I know, in CPython, by default, it's using 4 bytes for each character. That's what I think it is by default. But you can set this at compile time. I think you can change to another representation, but yeah, that's what I think it is. I'm not 100% sure. Is it heavier? No idea, to be honest. Okay, so people are telling me that we are really running out of time. So thank you again, and see you next time using Python 3.